Welcome back to Unit 11 on vectors, Day 2. We're going to discuss more on the law of sines, but we're also going to introduce what's called the ambiguous case. As a warm-up, take a look at this triangle. We're given these three dimensions, angle 34, sides 4 and 3. First find angle x, then find the area. There's the solution to that problem. I first found angle B to be 48 degrees using the law of sines. Then I found angle C to be 98 by subtracting from 180, giving us a corner area of 1/2 AB sine of C, 1/2 4 times 3 times sine of 98, 5.9 square units. Excellent. All right, so the ambiguous case. First of all, in geometry, we knew that SSA never guaranteed triangle congruence. Why? Here's why right here. We take a look at this triangle. We could have this given angle. We could have this given side. And we could have this given side. Does that guarantee the triangle has to look like that? It doesn't. If I took this side, hinged it into here, I would still have, let's call that a capital B, I would still have that angle, side, side, but a very, very different triangle than I just had a minute ago. So how do we use this law of sines to apply on this ambiguous case? Well, we have a strategy. We have some steps that we're always going to go through. Let's take this example. Angle A is 24 degrees. Side A is 8. Side B is 10. It is that side-side angle. Ambiguous case option. We're always going to create this grid with two different triangles possible. Angle A is given, 24. Has to be 24 both times. Let's find this initial angle B. Sine of 24 over 8 equals sine of B over 10. 8 sine of B equals 10 sine of 24. Divide by 8, take the sine inverse. Sine inverse of, that decimal is 0.67789. So that angle X, or in this case angle B, is 43 degrees. Now what I would do is complete that triangle 1. 24 plus 43 plus what gives you 180? Angle C has to be 113 degrees. That would be this option right here where C is the bigger angle. But what about the other one where A is 24? Side A is 8. Side B is 10, but B is now the obtuse angle. How do we find those pieces? Here's how. Once we get that angle 43, we're first going to take the supplement of that 43, because if we draw the side down there, that angle creates an isosceles triangle, hence 8 and 8. So if this angle is 43 degrees, so is this. And that's 43 degrees. That is 180 minus 43, 137. 24 plus 137, subtracted from 180, that leaves that angle C to be 19 degrees. That would be the two different options for triangle 1 and triangle 2 with this 24, 10, 8 setup. Again, ambiguous case. SSA, set it up, two triangles possible. Let's try it again. Angle B, 58 degrees. Side B, 15. Side A is 12. Do we have that angle side side? We absolutely do. So let's create our two triangles. This time we know angle B. We don't know A. We don't know C. B has to be 58 no matter what. Let's create a law of sines to first find that angle A. Sine of 58 over 15 equals sine of A over 12. Cross multiply. Sine A equals 12 sine of 58 divided by 15. Take the sine inverse of that decimal, which I got to be 0.67843. Angle A is 43 degrees. I'm going to plug that in right here. But before I find angle C, that's the strategy we're going to take. We're going to say, what's the other possible angle A? 180 minus 43 is 137. When we plug that in right here, what's the problem? 137 plus 58 right there is over 180 degrees. Hence, there's not a second triangle possible. There's only triangle 1. And if we finish that out, angle C is 79. And we could solve for side C. So that's an example where side-side angle does just generate one triangle, not two. Showed up when the supplement, there were too many degrees to have triangle 2. Let's take a third example. Solve the triangle. If more than one triangle is possible, find both. Before we draw it, let's take a look at what we're given. Side A and angle A, side B sure sounds like a side-side angle. 85, 15, 25. Let's create a law of sines equation. Sine of 85 over 15 equals sine of B over 25. Cross multiply. Sine of B equals 25 sine of 85 over 15. B equals sine inverse of 1.6603. Problematic. No triangle possible. How is that? Well, let's take that exact idea and let's exaggerate it. You have a large angle, 85 degrees. You have a side of 25. This side right here is 6. There is absolutely no way that 6 reaches down here to connect to make a triangle. That would be the no triangle possible. So, in this ambiguous case, when given side-side angle, there are 3 possibilities. There's a situation where you could have 2 different triangles possible. One triangle only, or no triangles. And we must test for each of those possibilities every time we're given the side-side angle. Let's do one more. Draw it. Angle C is 53 degrees. Side C opposite is 5. Side A is 6. We don't know A, we don't know B, we don't know side B. Do we have the SSA? We do. Our process now is to create a 2-triangle chart. We know angle C. We don't know B, we don't know A. This time, I'm going to include side B. Make it a complete solution. Create a law of sines equation. I have my side angle pair. Sine of 53 over 5 equals sine of A over 6. A equals 73 degrees. Let's put that in for A. What's the other option for A? Let's do that before we even find our angle B's. 180 minus 73 is 107. 107. Are there enough degrees in triangle 2 to have an angle B? There are. This looks to me like a 2-triangle case. C is 53, A is 73. For this triangle, that leaves B to be 54. For this triangle, that leaves B to be 20. What side of B look like? Let's create a law of sines here. And I'll try to draw my shape to scale as well. Sine 53 over 5 equals sine 54 over B. Cross multiply. B equals 5.1, which makes sense since 53 and 54 are so close to each other. I would expect side B to be very close to 5. On the other side, sine of 53 over 5 equals sine of 20 over B. This B would equal 2.1. Again, given SSA, law of sines, yes. Ambiguous case, triangle 1 works, as does triangle 2. One more example. You work this through. I'll pause, and then you can check your work. As you can now see, it is an angle side side law. Sorry, let me start again. As you can see, it is an SSA ambiguous case law of sines, but it is only one triangle possible. The unknown angles we found to be 21, 117, and the unknown side to be 29.3. Again, law of sines today, ambiguous case SSA, one triangle, two triangles, or no triangles possible. Work on today's problems, get a little bit of practice on that. Tomorrow is law of cosines.